Welcome to Topic 8 in the Management and Administration in Medical Imaging series. I'm B.R. Shasendrao Balakrishnan, and in this session, we'll explore the vital aspects of department planning, layout, and design within a medical imaging setting. These elements are crucial for creating an efficient, safe, and patient-friendly environment that supports staff workflow and optimizes the use of technology. Together, we'll examine how thoughtful planning and design can enhance operational effectiveness while meeting regulatory and safety standards. By the end of this session, you'll be able to explain the importance of project management in the design and layout of medical imaging departments, emphasizing how effective planning contributes to successful implementation. You will also be able to identify the key components of a typical imaging department and understand their roles in optimizing workflow and enhancing operational efficiency. Additionally, you will gain insight into the impact of digital imaging technology on department layout and workflow, including critical considerations for designing workstations and radiologist workspaces that support productivity and ergonomics. With rapid advancements in investigative technology, the field of radiodiagnosis and imaging services experiences continuously evolving demands. This dynamic environment necessitates advanced and detailed systematic planning and organization to effectively manage resources and workflows. Successful planning also requires foresight into future developments and anticipated requirements, ensuring that the department remains adaptable and prepared for emerging technologies and changing patient needs. The primary objective of the department is to provide comprehensive, high-quality imaging services that support accurate clinical diagnosis. In addition to diagnostic imaging, the department is committed to delivering high-quality therapeutic radiology. Furthermore, it places a strong emphasis on training and research to advance knowledge and skills within the field, ensuring continuous improvement in patient care and technological innovation. Let us now take a look at the proposed layout of an ideal medical imaging department. This floor plan has been carefully designed based on best practices in radiology facility planning, incorporating principles of workflow efficiency, radiation safety, infection control, and patient-centered care. The layout promotes a logical patient flow from registration and preparation areas through various imaging suites and finally to reporting and discharge, with clear separation between clean and dirty zones, inpatient and outpatient routes, and staff versus patient pathways. It includes dedicated rooms for all major imaging modalities, such as MRI, CT, general X-ray, ultrasound, fluoroscopy, mammography, and dental radiography, as well as necessary support spaces like control rooms, changing bays, reporting areas, recovery bays, and staff workspaces. Importantly, this plan is scalable, future-proof, and aligns with both international accreditation standards and local regulatory requirements. In the following slides, we will study each section of this layout in more detail, examining the design considerations, safety features, and functional workflow for every imaging modality. Certainly, here's a general overview in paragraph form for the magnetic resonance imaging, MRI, section, based on a floor plan and your previous notes. The magnetic resonance imaging, MRI, suite is a highly specialized and controlled area within the medical imaging department, designed to ensure patient safety and operational efficiency. The layout follows the standard zoning system, Zones I through 4, to maintain magnetic safety and regulate access. Zone I comprises public spaces, such as reception and waiting areas. Zone 2 includes supervised transitional areas like the changing room and holding bay, where patients are prepared for MRI. Zones 3 and 4 represent increasingly restricted environments. Zone 3 contains the control and computer rooms, accessible only to screened patients and trained MRI personnel, while Zone 4 is the MRI scanner room itself, marked by high magnetic field strength and requiring the strictest access control. Clear signage is essential in this area, with caution signs used at Zone 3 and danger signs at Zone 4 to alert staff and patients about restricted access. The design of the MRI room must adhere to specific structural requirements, including a minimum floor area of 40 square meters, a room height of 3.4 meters, and walls with a thickness of 230 millimeters. Moreover, both magnetic shielding and radio frequency shielding are required and must be customized based on the specifications provided by the MRI equipment supplier. An emergency cart, e-cart, is also positioned nearby to provide immediate response in case of patient emergencies. Overall, the MRI suite is thoughtfully designed to support patient preparation, scanning, and post-procedure recovery in a seamless workflow, while prioritizing safety through zoning, structural requirements, and shielding measures. In the following slides, we will explore MRI planning, safety protocols, and operational details in more depth. The Magnetic Resonance Imaging, MRI, suite is a specialized zone in the medical imaging department that requires stringent safety measures and carefully structured access control. The layout adheres to the four-zone safety model recommended for MRI environments. Zone 1 serves as the public access area, often shared with the general radiology department, including the main entrance and general circulation space. Zone 2 typically comprises the reception, patient waiting area, screening station, toilet, and changing rooms, spaces where patient interaction and initial preparation occur. Zone 3 is restricted to authorized and screened individuals only. It houses the MRI holding and recovery bay, control room, equipment room, and related technical support areas. Zone 4 is the MRI scanning room itself, designated as a high-risk area, where magnetic field exposure is strongest and strictest access control applies. To ensure patient and staff safety, clear signage is posted throughout, including caution warnings at Zone 3 and danger signage at Zone 4, restricting unscreened personnel and ferromagnetic materials. Access to each of these zones is controlled to minimize risk, and only trained MRI personnel may enter beyond Zone 2. The presence of an emergency cart, e-cart, nearby ensures readiness for urgent medical situations. The physical structure of the MRI room must accommodate specific requirements such as adequate shielding, both magnetic and radio frequency, which are determined in collaboration with the equipment supplier according to the MRI system specifications. The zoning and support infrastructure of the MRI suite are designed to streamline patient workflow from reception through to scanning, while meeting safety and operational standards. In the following slides, we will explore the MRI modality in detail, including planning considerations, equipment layout, and patient handling procedures. The MRI suite requires highly controlled planning due to its unique safety and operational needs. Access to the MRI area must be restricted and carefully zoned, typically into 4 zones, with zones 3 and 4 being the most controlled. The MRI room, Zone 4, houses the magnet and must be supported by adjacent spaces, including a control room with full visual access to the patient during scanning, changing rooms equipped with lockers for personal belongings, and clear signage indicating restricted access. Patients and staff must be screened thoroughly, as items containing metal, such as keys, watches, or credit cards, are prohibited within the scan room. A wall-mounted metal detector and strong magnetic hazard warning signs must be installed at the entrance to the MRI room. The boundary of the 5 Gauss magnetic field should be clearly marked, typically using a red line, to signal the outer limit of potentially hazardous magnetic exposure. These safety elements are non-negotiable in ensuring the protection of both patients and healthcare staff. The construction of imaging rooms, especially those dealing with radiation, requires specific materials and shielding to ensure safety and compliance. The walls are constructed using a double layer of 114 mm clay bricks finished with 20 mm barium plaster on both sides, offering effective radiation protection. For thermal insulation and fire safety, Class O polyurethane foam is used between wall layers and finished with Class O polyurethane paint. The walls are designed to provide a 2.0 mm lead PB equivalent shielding suitable for typical radiographic energies. For access control, the control room features a single leaf door, 2,100 mm x 900 mm, with a hollow core and 2 mm lead lining, mounted within a metal frame to protect against exposures up to 150 kV. Similarly, the examination room is equipped with a double leaf swing door, 2,100 mm x 1,500 mm, with the same lead equivalency, including kick plates and trolley access, making it suitable for patient transfers. A crystal-clear lead glass viewing window, 1,000 mm x 600 mm, is installed in the control room wall at a height of 1,200 mm from the floor, allowing visual contact with patients during examinations. To maintain radiation integrity, no other windows are allowed in the examination room apart from this dedicated lead glass panel. This slide summarizes the essential room size and radiation shielding requirements for various radiographic apparatus. Different types of X-ray equipment require specific minimum room dimensions to accommodate the machinery and provide adequate workspace. Generally, rooms range from about 2.0 m x 3.0 m for smaller equipment like dental X-rays, up to around 6.5 m x 4.5 m for larger systems such as angiography. Radiation protection is ensured by applying lead shielding in walls, doors, floors, and lead glass windows. The typical shielding thickness is 2.0 mm lead equivalent, with some variations depending on equipment type and location. For example, dental and mammography rooms have slightly thinner shielding. Additional lead protection is required behind the chest stand and underfloors in upper-level rooms to prevent radiation leakage. Lead glass windows are installed to allow operator visibility while maintaining safety. Together, these specifications create a safe environment for both patients and staff while accommodating the technical needs of the radiographic apparatus. The CT scan room must have a minimum internal dimension of 5.5 meters by 4.0 meters to ensure sufficient space for safe equipment operation and patient movement. The control room is located outside the procedure room to protect operators from direct radiation exposure. Walls and doors require 2.0 mm lead equivalent shielding to effectively block harmful radiation and protect adjacent areas. A lead glass window measuring 100 centimeters by 50 centimeters with the same lead equivalence is installed to allow the operator to observe the patient safely without exposure. Radiation warning lights and signage, including pregnancy warnings, are placed on all doors to alert staff and visitors of potential radiation hazards. Doors with a clear opening of at least 1.2 meters facilitate easy access for stretchers and beds, ensuring smooth patient transport. The CT room contains no other windows besides the lead glass to maintain controlled radiation protection. The minimum dimension for a general radiography room, with the control panel located outside, is 2.0 meters by 4.0 meters, providing sufficient space for safe patient positioning and equipment use. The walls and doors require shielding with 2.0 millimeters lead equivalent to protect adjacent areas from scattered radiation. A lead glass window measuring 35 centimeters by 30 centimeters, also with 2.0 millimeters lead equivalents, is installed for exposures above 100 kVp to allow safe viewing of the procedure. Radiation warning lights and signage, including pregnancy warnings, must be placed at all entrances to alert staff and visitors of radiation hazards. Doors should have a clear opening of at least 1.2 meters to ensure easy access for patient stretchers and beds. Importantly, the X-ray beam must never be directed toward occupied areas such as waiting rooms, control panels, or film pass-through hatches to prevent unnecessary radiation exposure. Behind the target board chest stand, the wall must be shielded with lead measuring 1.2 meters by 1.2 meters with a thickness of 2.0 millimeters Pb, equivalent to protect against direct radiation. The mammography room must have a minimum dimension of 2.5 meters by 3.5 meters, with a control panel located inside the room to allow immediate operation and patient interaction. The walls and doors require shielding with 1 millimeter lead equivalent to provide adequate protection against scattered radiation, which is lower than general radiography due to the focused nature of mammography. A lead glass window measuring 35 centimeters by 30 centimeters with 2.0 millimeters lead equivalents is installed for safe viewing during procedures. The doors must have a clear opening of at least 1.2 meters to allow easy patient access, including stretchers if needed. Radiation warning lights and signage, including pregnancy warnings, are required at all entrances to alert staff and visitors. Additionally, lead shielding extends up to 4.5 feet on the wall of the patient waiting area to protect individuals from stray radiation. The OPG, orthopantomogram, room requires a minimum internal dimension of 2.5 meters by 3.5 meters, with a control room located outside the procedure room to minimize operator exposure. The walls and doors must be shielded with 1.5 millimeters lead equivalent to protect adjacent areas from scattered radiation. Doors should have a clear opening of at least 1.2 meters to allow easy access for patients and equipment. The viewing window is designed to provide a full view of the OPG machine and the patient at all times, including during machine movement, ensuring safety and proper monitoring. Radiation warning lights must be installed at external doors, and appropriate radiation and pregnancy warning signage should be displayed at the double swing entrance doors to alert staff and visitors. The fluoroscopy room requires a minimum dimension of 6.0 meters by 4.0 meters to accommodate the equipment and patient movement comfortably. The control room is positioned outside the procedure room to reduce operator exposure to radiation. Walls and doors must be shielded with 2.0 millimeters lead equivalent to ensure adequate protection from scattered and direct radiation. A lead glass window measuring 100 centimeters by 50 centimeters with 2.0 millimeters lead equivalents allows safe observation of the procedure. Doors must have a clear opening of at least 1.2 meters to facilitate patient care and allow easy access for stretchers and beds. Radiation warning lights are installed at all outside doors, accompanied by radiation and pregnancy warning signage at both entrances to ensure safety awareness. The bone densitometry room should have a minimum size of 2.5 meters by 3.5 meters to accommodate the mobile equipment and allow sufficient space for patient positioning. The control area is located outside the procedure room to minimize radiation exposure to the operator. Walls and doors require shielding with 2.0 millimeters lead equivalent to provide adequate radiation protection. Doors must have a clear opening of at least 1.2 meters to enable easy patient access and movement of equipment. Radiation warning lights are placed at all exterior doors, and radiation as well as pregnancy warning signs are displayed at both entrance doors to ensure safety compliance. The mobile area should have a minimum bay depth ranging from 0.8 to 1.2 meters and a length of 5 meters to allow sufficient space for maneuvering and parking mobile equipment. This area must be located away from the main corridor to avoid obstructing traffic flow and ensure safety. Adequate power outlets should be installed to support charging requirements of the mobile devices, and LAN sockets are necessary to provide a reliable wired connection for Wi-Fi access. Additionally, designated parking spots for the machines should be clearly marked with tape to organize equipment placement and maintain orderly workflow. Thank you all for your attention and time today. If you have any questions or would like to discuss further, please feel free to reach out. Have a great day.